welcome to, what day is it? Sunday's edition of Cracking the Cryptic. Now, apologies, some of you may be wondering what time this video is coming out, and that is because the clocks changed in the UK last night. They sprung forward by an hour. So I guess if your clocks didn't change last night, this video is probably an hour earlier than you were expecting it. But this should be something rather special today. This is called Killer Shikoku. I think that's probably how you spell that. It's by the Cogito, and this puzzle has completely flummoxed some of our testers. Mark has looked at it. Mark has changed the rules of it, I believe, to make them clearer. And he says it is an absolutely extraordinary puzzle. The first line of the rules is normal Sudoku rules mostly apply, which is a bit worrying. Anyway, this is what our task is today, so we're going to have a look at this in just a moment. Do I have anything to tell you? Yes, I do. I embarrassed myself wholly earlier on today by recording a video of me solving the Sunday Times puzzle number 5000, which has appeared in the UK today. That's extraordinary, because if we take it that there's approximately 50 Sundays in a year, that means that there's been 100 years worth of Sunday Times Sunday puzzles, which is quite incredible. But that puzzle really really bashed me about a bit. So if you like your cryptic crossword content, I'll probably post that on the channel tomorrow morning if I get a chance. So that'll be something for you all to amuse yourself laughing at my misfortunes in. I don't have anything else to tell you else. Let's get on with this puzzle, and I'll read you the rules. Now, hang on. Killer Shikoku. It sounds like Shikaku, which is a logic problem, but it's not Shikoku. I don't know what this means. Anyway, the rules are as follows. Normal Sudoku rules mostly apply. However, the grid contains no fives. Instead, every row, column and box has a single repeated digit. NB. Beware. This does not mean that you could find 9 cells in which 5s could be placed to make a genuine grid. I've got no idea what that means. Additionally, divide the grid into rectangular regions of orthogonally connected cells. Each rectangle contains exactly one circle. Each rectangle contains exactly one circle. Okay, a single cell with a circle counts as a 1 by 1 rectangle. A number in a circle represents how many cells are in the rectangle the circle belongs to. So that is a rule like Shikaku. So Shikaku is a logic problem where you have to divide a grid. Normally it's not a square grid, but a grid into sort of rectangle, where, if this was one of the rectangles, you would find an 8. Yeah, this is a bad example. You'd find an 8 in its circle. I've managed to put 3 circles into this rectangle. So, but hopefully that gives you an idea. So we've got to divide the grid into, rectangles like this. Let me just try and see if we can come up with something very quickly that looks like it might pass muster. So now it's getting tricky, look, because that's going to have to be a solitary one. This would have to do, well, it wouldn't have to do that. And I've broken this anyway, because this, oh no, I could just extend this one. There we go. Let's make that one bigger. So you can see, we're starting to propagate this, and we're starting to try and cover the whole grid in rectangles. That is the job of Shikaku, but this is called Shikoku. Let me just finish reading the rules. Rectangles cannot overlap. Every cell in the grid is part of a rectangle, and digits may not repeat in a rectangle. So that's interesting, because that means we can't have any ginormous rectangles in this puzzle, because if we did, if I try and do that, for example, as a rectangle in this puzzle, you'd have to have 12 different digits in that purple region, and that won't work. There are only 9 different digits in a Sudoku. So they are the rules. The bit of the rules I didn't understand was the bit that said, beware, this does not mean that you could find 9 cells in which 5s could be placed to make a genuine grid. So what that's saying is, although there are no 5s in the grid, so let's just sprinkle some 5s around this grid. Let's imagine these were the 5s. and here. So if they were 5s there, whoops, those two have interloped. Oh, well, hang on, I've managed to get, I'm going to have to imagine this is a 5, or I'm going to have to flick these round. Hang on, let me flick them round, because I don't want this to be confusing. So we've got to put a 5 here now. So let's imagine they were the 5s. What we're being told is that normal Sudoku rules mostly apply, however the grid contains no 5s. Instead, every row, column and box has a single repeated digit. So the 5 in this row, if this was the 5, or where the 5 might have gone in this row, whatever it is now will lead to a repeated digit in the row. But we're being told that this is not what we do here. We can't imagine that this grid has a sort of some layout of 5s, which, oh, I think this is horrible actually. Perhaps, well, horrible in a bamboozling way, because I think what we're being told here, whoa, okay. Right, I think what we're being told here is something a bit different. I'm going to duplicate this tab and go back to the beginning. Because I want to explain what I think is going on here. So let's imagine that this row was filled like this. 6, 7, 8, 9. So you can see here I've got double 1. So that would imply, because there's no 5 in this row, if we were to imagine that the 5s were hidden, one of these two would be a 5. But I think what we're being told is it might be possible. How's this going to work? I'm not going to be able to work this out on the fly, I don't think. It might be possible, for example, for there to be 2 8s in this column and 2 4s in this column. Would that? So this column now, that would imply there was a 5 in one of those two, and that would imply there's a 5 in one of those two, but you can see that's contradicting what's going on in row 4, where it seems that this one of these two has to be the 5 because there's a repeated 1. I think that we are being told that this is possible, that basically we have to work out, well, we have to almost ignore the fact that in a normal Sudoku you'd expect there to be a 5 in every box, row and column, and instead focus on the rule that says in each row, column and box there is 1 repeated digit. So we've got to ignore this idea around 5s replacing the repeated digit, because that is not what is going on. That is very, very difficult to understand for me. I've no doubt you guys have all understood it completely, but anyway, do have a go. The way to play is to click the link under the video as usual. Now I get to play Let's Get Cracking. Now what I don't think I can do here is write 1 in there by Sudoku, because these ones are effectively, well, they might be lying to us. Is that how to think about this? That these might be lying? That these... No, I can't think of them as maybe having a 5 in one of them. Yeah, no, this is weird. This is so weird, because I could have a repeated 1 in this row. So I could have a 1 there. And then I could have a repeated 1 in this row, and it could be there. And then this definitely can't be a 1, because there's already 2 1s in the box. Oh, this is mad. This is absolutely mad. I've got no idea. Do I have to start this with the circles then? I don't think digits in this puzzle, they're almost unhelpful because they're misleading. Yes, okay, so maybe we start with column 1. At least I can see that those 2 cells are restricted. And they're restricted by the Sudoku logic, because these cells can't, well, if given that rectangles that we build can't overlap, so we can't put 2 circles into a region, this can only come down 2 cells, so that must be a 1 or a 2, and that must be a 1 or a 2, and that immediately seems to have broken the puzzle, because I've now got a repeated 2 in column 1. So that's telling us that in column 1, the rest of the digits in this column are normal digits. And when I say normal digits, I mean digits other than 2 and other than 1 and not 5, because there's no 5s in the puzzle. So these are 3, 4, 6, 7, 8, 9. Now Mark would be tremendously proud of me for pencil marking those cells in. Now again, what I want to do here is to delete 3 from these, but I don't think I can, because there could be 2 3s in box 4. So again, I see. So I can use the Sudoku again, look. 2, 3, 4, 5. Yeah, oh, I can. Yeah, okay, this is quite interesting. So these 2 cells, I don't think either of them can have a 6 in them. Because if they did, well, I think the maximum size of the region, the rectangle I can build in them is 5. If I go further, I'm going to hit another circle. So if that's right, I think those are in fact a 3, 4 pair. And does that mean I can eliminate? It does. I think I can eliminate 3s and 4s from there, leave the rest of this column, because the repeated digit in this column is definitely a 2. And I can't have 2 repeated digits in a column. So can I view these? Oh no, I've just realised something horrible. Oh my goodness me. I've been viewing these as a 1-2 pair. I think actually they are a 1-1 pair. Now does that affect any of the logic I just did? Whoa, that's so weird. Yeah, it's totally bamboozled me, unsurprisingly. But when I viewed these 3 cells together, let me highlight them. I said these were a 1-2 pair, and therefore there was a repeated 2 in the column. That's not true. It's not necessarily true, because of course these 2 circles could be a double 1 pair, and there would be a repeated 1 in the column. Now, I still think it's true to say that the orange squares contain a repeated digit. It was just a 1 or a 2, not necessarily a 2. And that means the logic I did on the rest of the column was still okay. That gets me to a 3, 4 pair in these circles, which is really interesting, because 3 plus 4 is 7. And that means that the Sudoku in these 2, emanating from these 2 circles, is going to consume 7 of the cells in this column, which actually means these are a double 1 pair. And that means we can Sudoku them. We can enclose them using our popular pen tool. By the way, if you don't know how to get the pen tool, just click that, the cog icon on the right of the grid, and click Enable Pen Tool. I always have my pen tool turned on, but that's how to get it if you're struggling. Now what do we do? So now this column sort of exists outside of the rest of the puzzle, doesn't it? We can draw this line in, because once we work out which of these is 3 and which of these is 4, we're going to divide these 7 cells up. Right. Okay, well, let's carry on. So I think we can do the same thing with those 2 cells now, because those 2 cells definitely can't be greater size rectangles than size 2. So these are a 1 and a 2, but they are not a 1-2 pair necessarily. They might be a 1-2 pair, but we don't know that. What we know now is that there is a repeated 1 or 2, depending on what this digit is, in box 7. So the rest of this box is is normal digits. So that means that, what does that mean? So that means that these cells have got to be from 3, 4, 6, 7, 8 and 9. I really want to use this 6, 7, 8 triple here. I'm not sure it's legitimate to do that. Let's pencil everything in. 3, 4, 6, 7, 8, 9. Now we've got a 3 here. And we've got a circle here. And this circle has the same logic as this circle had. This can't be a 6 because there's not space for a 6. So that's a 3 or a 4. Now that means I've got a 3, 4 pair in this box. Yeah, that's okay, isn't it? That's a real 3, 4 pair in box 7 because we know the repeat is happening in 2 of these 3 cells. So this 3, 4 pair can be used to eliminate 3 and 4 from these squares, where I've now got a 6, 7, 8, 9 quadruple in box 7. Now, how do I use that with this? I've now got a 6, 7, 8, 9 quintuple, which sounds weird to say, but so that means one of these digits in row 8 is a repeat. And that you can't repeat the digit in box 7 because the repeated digits already happened in box 7 in this little L shape here. So that means that one of these 2 digits repeats in one of these 2 cells. Now that means I want to say that means one of these 2 cells is a 9. I think that's true, isn't it? Because if there wasn't a 9 in these 2 cells, we'd have 2 repeated digits, or 1 digit that repeated 3 times in row 8, and that's clearly nonsense. Not that the rest of the puzzle makes total sense to me, but that really would be nonsense. So there must be a 9 in one of those 2 cells, which means there must not be a 9 in one of those 2 cells, because if there was, there would be 2 9s and 2 of whatever is repeating here in box 7, and that's clearly so ridiculous, I cannot tell you. Now, the other thing we can say is because we know the repeated digit is a 6, 7 or an 8, in row 8, the rest of this row is normal and must be the other digits, which are not the digits that are not 5. So this is 1, 3 and 4. I just want to use the 4 and get rid of it there, but I think this could be a 4, and there would be 2 4s in this column. Now, that's not a 7 because that's in a circle, and if it says 7 is prime, these are the knowledge bombs we share with you on Cracking the Cryptic. But if 7 is prime, if you think about it in terms of rectangle logic, it can never be in a sort of anything other than a stripe like this, because at the moment we rectangularize it, we're saying it's divisible by something other than 1. You know, it would have to be this, so divisible by 2 if it's like that, divisible by 3 if it's like that, etc. Well, prime number's only divisible by 1, so it's got to be a stripe. Now, a 7 stripe is going to bump into this or this, so that doesn't work. So this is 6 or 8. Now, if it's 6, it's going to have to... It can't be 6, actually. It can't be 6, because that's going to repeat the digit in the rectangle. 2, 3, 4. No, it doesn't. If it's 6, it can't consume the bottom row. There's only 5 cells for it, so it has to come up here. Then it has to take those cells, and this being a 6 and that being a 6 would share a rectangle, which is against the rules. So that is an 8, and it's an 8 that must do that, I think. So that is a shape that we have discovered. In fact, do I need to? Maybe I don't need to highlight the colour of it, but what I can do is rectangularize it like that. Now, is it legitimate to remove 8? No, Is it legitimate to remove 8 from these? Yes, it is, because yeah, this is the repeat in box 7, so I can't have a second repeat, so it is legitimate to remove those. That is a 9 by our old friend Sudoku, which only mostly applies in this puzzle, but it does apply within Shikaku boxes. So we can't repeat a 6 or a 7 in this box. So that's a 9, which is a little bit of a thing, isn't it? So now the repeated digit in row 8 is this digit and one of those two digits. And this 8 cage, oh, right, the 8 cage does not have a 5 in it, so it has every other digit in it, because it can't have a repeated digit. So these are 1s, 2s, 3s and 4s to complete this weird cage. Now I've broken, no, I haven't broken the bottom row, but I've got 5, I've got a quintuple on the numbers 1, 2, 3 and 4. So the repeated digit in row 9 is a 1, 2, 3 or 4. Which means that the rest of this row must be non-repeated digits that complete the complement of digits from 1 to 9 excluding 5 inclusive, if you see what I mean. So that means these digits are going to be 6, 7 and 9, and that is in a circle. And again, it can't be a 7. If it's a 7, it's going to be a stripe, it's going to hit things, and that won't do. Now it's a 6. If it's a 9, it can fit in. Look, it can do that. Although then I'd have to put 5 in the... Yeah, this is right. This can't be 9, because if it's 9, you can't repeat a digit in two of the rules conflict, because we can't repeat a digit in the Shikaku shape, but we also can't include a 5 in the Shikaku shape, because there are no 5s in the puzzle. So we would have to repeat a digit, and then we would break the rules. So this square here is a 6, I think, which means... Now, I was about to say these can't be 6s. Is that... Yeah, no, that is true. They can't be 6s because the repeated digit has already happened in this row somewhere else. So these two cells are 7 and 9. And that 6 has to go upwards. It has to take this cell here. But after that, we don't know what it does. It could do lots of different things. Well, not lots of different things. I think it can only do 3 different things. I'm not sure how those things necessarily help us. Wow. Okay. Right. So what do we look for now? We shall have a look at... we are going to take a look at column 2. I've got a 1, 2 pair, but is that's not... That might be real, might it, or it might not be real, in the sense that one of those digits might be wrong or repeated. So, right, that digit's got a restriction on it by not... Again, I think the only way of doing this puzzle is not to do Sudoku. It's almost to ignore... This puzzle should be perfect for me. You know, i.e. just don't do any Sudoku, because if you do Sudoku in this puzzle, you'll probably get it wrong. So what we've got to do is keep focusing on Shikaku, and this cell, again, can't be greater than 5. It can't be greater than 5. There is not 5. There's only a 5 rectangle possible, and it can't be a 5 because I'm not allowed to put 5 in the puzzle. So its maximum value is 4. So this is 1, 2, 3 or 4. And that gives me a 1, 2, 3, 4 quintuple in column 2, which means that the repeated digit is happening in those 5 cells, which means the other cells in this column have got to be real. And they've got to be 6, 7s, 8s and 9s. That means I've got 6, 7, 8, 9 quintuple in box 4. So the other cells in here have to be the other digits. So we've got to put 2 and 4 into those cells. Now, no, I can't do that, can I? I was about to use it to disambiguate the 2, 4, but I think this could still be a 4. Because from the perspective of the row, I haven't found the repeated digit yet. I'm good. I'm looking forward to the comments on this one. I think this is mental. It's absolutely mental. Now. I've got a 6, 7, 8, 9 quadruple in row 2. So these other digits have to be low digits. That has given me a quintuple on a quadruple in box 1. 1s, 2s, 3s and 4s appearing in 5 different cells. So these squares have to be from 6, 7, 8 and 9. And now, there must be a 9 in row 2, because there's one of every digit apart from 5 in every row, column and box in this puzzle. It's just there's 2 of another digit. So there must be a 9 in this row, so there's a 9 in one of those 2, which means there's no 9 in those 2, because if there was a 9, we'd have 2 9s and a repeat of 1, 2, 3, 4 and 5. So now I've got something going on in this column, look. Oh no, I already knew this. I've got... okay, but the repeated digit in this column now is a 6 or a 7 because it's this digit and one of these 2. You can't have the repeat in box 1 or it'll be a second repeated digit in box 1. Now, how on earth? I mean, this is so crazy. I mean, this has been said by a very strange mind indeed. How on earth do you come up with this stuff? Is that one? Right. This one is interesting. Actually, this is beautiful logic, to be honest. I mean, it may be mad, but this is very beautiful. What is this from a rectangular point of view? Now, what it is not is a 2 by something. Because if it's a 2 by 3 to make 6, it would have to do that, and there would be a repeated 6 in the rectangle. If it's a 2 by 8, it picks up this one, and there's a repeated 8 in the rectangle. So it must just be something that goes along the top row, and therefore it can't be an 8, because if it's an 8, it goes off the edge of the grid. So that cell is a 6 or a 7, and does that mean those are a pair? No, I don't know. I don't think it does. I'm not sure. I'm not sure, but we know that this goes along here. It must go at least 6 cells. 1, 2, 3, 4, 5, 6. So all of those cells are part of the same region, but this one might be as well if this is a 7. Let's put that in like that. Like that, maybe, to show that we've got one more cell still available to us. Now, yeah, okay. So now I can see that this cell has to be part of that one, doesn't it? This one can't be part of the blue one, and it can't be part of that one because that's only able to be a 1, 2, 3 or 4, so it can never reach this one. This one can't reach it because it can't bend. That's not a rectangle. This one's got the same problem. I don't think anything can get to this apart from that, so I think that's forced. Now, Oh, right. Okay, here's something. This one is now interesting, I think. Because it can't be a stripe. If it's a stripe straight down, it's only got 5 cells to fill. So it must come out. And once it comes out, we must make sure it retains its rectangularness. So it must take this cell in it. And now once this cell is in it, this cannot be a 6. So this is now, it can't be a 7. A 7 is a stripe, it's prime. So this is an 8. Oh, this is really beautiful. Good grief, right. You can't put the 8 in that configuration. You'd have 2 8s in the rectangle. So I think that's forced. Which is lovely. That means we can do that. Now we can't repeat 1 in a Shikaku, so this can't be 1. Got this 2 4 pair. Oh, yeah. This is good. I've got 2 8s in the column. So everything else must be legitimate from a Sudoku perspective. So that is a real 2 4 pair. That means I can remove it from there. That's a 3. Now what I can't do is then use this 3 to reduce these 2 down, because I know in box 1 there's a repeat in one of those. Okay, so what are the other digits then we've got to put in this 8 cage? Because it's got to have every digit apart from 5. So it's got to be 2, 4, 7 and 9. So there's definitely, from a pure Shikaku perspective, there is a 7 and a 9 in that triple. But they don't seem to eliminate anything down there. Right, but now column 2 has become restricted. Yeah, nothing else can interfere with column 2. By that I mean, this cell might have been able to get here like that, but it can't because this is a 3 or a 4. So this one, even if it took that cell, it's going to have to take this cell, and that blocks off the entrance of this one to column 2. So column 2, we know the circles add up to 9. There we go, there's a little deduction. Let's just fill that in. Now what I'm saying is I think these circles, because they are the only way of getting rectangles now into this column, these must add up to 9 to complete the column. So they must have there must be a repeated digit in yellow, because if there isn't, they'd be 1, 2, 3 and 4 and they'd add up to 10. Now 10 is greater than 9, so it's going to be probably double 1, 3, 4, I think. This is the same as this. Double 1, 3. Oh no, that doesn't. Oh, I've got 2 repeated digits, so I do that. That's weird. No, it's not double 1, 3, 4 because of this 3. Because if it's double 1, 3, 4, although that does add up to 9, you've got 2 1s in the column and you've got 2 3s because there's going to be a 3 in yellow. So that doesn't work at all. So there's got to be another repeated digit that's not double 1. So double 2. If it's double 2, so where can we have double 2? Let's just have double 2 on the edges. If you've got double 2 on the edges, you need to have 5 from the remaining 2 circles. And you can't use another 2, because then you'll have triple 2. A concept so ludicrous that I cannot... so you're going to have double 2, 1, 4. Now why does that fail? Double 2, 1, 4... that might work actually. I can't see. Obviously I've got 2 2s in the column, but I don't think I've got another repeated digit. Now probably that's it then, because double 3. No, double 3 doesn't work because this would be a third 3 in the column, and double 4 would require a 1 and a 0 along with the yellow. So it's double 2, 1, 4. So there's no 3 in the yellow cell. So that's beautiful, because that gives me this digit. That's the 4. So this is not the 4. And now we've got, within these yellows, we've got 2 2s and a 1. And this one now has to come up and definitely take those. It definitely comes up as far as the 3. Now, yeah, okay. So now things are getting interesting, because my repeated digit now in box 1, I still don't know what it is. I know which cells it is. I was about to say it's going to be a 1, but it's not necessarily 1. This could be double 2. This is so weird. It could be double 2. It's either double 2 or there's a 1 in one of those two repeating here, but it's that 2 of these 3 cells are the same number. That means the rest of the box obeys normal Sudoku rules. So Sudoku rules do mostly apply. So that 3 can cancel with that 4. Whoa, that's a 4. So that means that this 4 is taking these 2 cells at least, as well as itself. Now, does that mean this is a 3? Yeah, actually that's a 3 just using this 4. So that's a 3. And that's got to take the cell up. Oh, that's got to take the cell above it. So maybe this is all done now, is it? Yeah, once you know the order of the 4 and the 3, you can do column 1. So that's fine. We've actually done that. That's good. The Shikaku in column 1 is finished. And that means... I don't know what that means. Probably means something. I don't know what to do. It's... How long have I had? I've had nearly 40 minutes on this. I don't know. I don't know. I feel like I should be able to resolve this, but I can't see how to do it. No. Okay. Right. Ignore Sudoku. Try and do Shikaku. I think that's what we're going to do. What about that one? Whoa. We're having an extra bonus of X's and O's in there. Right. So what's this cell? It's a 1, 2, 3, or a 4. So it never gets here. What's that one then? That one is that one, I think. That seems to be true, actually. I think those two have to join together on the basis that nothing else can reach row 2, column 5. Now, right, that's perfect. That's a 6 then. Because if it's any other number, it's going to have to be higher than 6. And it's going to have a repeated digit in its rectangle. So that is 6, and it's just fill it. I can just fill it in. So... yeah, this is the way to do this puzzle, isn't it? We have to keep focusing on Shikaku logic. And so now I want to say that this cell here has to belong to this one, I think. Is that fair? What else could reach that? Nothing. So those 3 are in the same region. We use green for that one. But this one could go here. Could be an 8. Could be a 6. Can't be a 9. We've got to remember, we can't put 9 into any circle. Okay, we've also got to be a bit careful. I was thinking about this digit. So what's this part of? And I think it's got 2 choices. No, well, it's got 3 choices, but one of those I can rule out. This cell cannot be part of that one, because if it is, that's going to have to be of size 5, and that will require us to put a 5 in the grid, which is clearly not allowed. So this cell is either part of this one or this one. Now if it's part of that one, how does that work with the puzzle? Does that give us a problem or not? Yes, that does give us a problem actually. Let me show you. So if this is joined to this, we've got a problem here now with this little sort of hexomino, because we need nothing. This can't get into this hexomino, this can't get into this hexomino, so this hexomino needs to be filled by just this one, and that is not a rectangle, that is a pipe, and that won't work. So that means that this cell is actually green. Now the moment that's green, and this could be a 6, which would be nice because it would give us a repeated digit in this column. But if it's not 6, it's 8, so it's a 6 or an 8. Aha! So if it's 6 or 8, we do now know the repeated digit in this column is 6 or 8. We just don't know which it is. So we know the rest of the column behaves itself and isn't naughty. So that is not a 1. Now, if this was an 8, then let me just have a quick look at this. That would have to be 1. That would have to be 1. This would have to join to here. That would be fairly flexible. Actually, that might be totally possible. If it stays at size 6, I think it's got even more options actually. Right, this digit now though has to be part of this. So we can now ink in that as a region. Oh, that's part of the 6. And if this cell joined to here, it would actually have to join up there as well, because it couldn't be of size 5, so we'd have to have a region like that. But that might be possible. Okay. I'm going to give this a colour just so I can feel like I'm making progress. So now what do we do? I've got a 3 here. Does that mean I can remove 3s from those cells, or is that... No, that is true. That is true, because I know that these cells provide the repeated digit in row 2, so these are not 3. So this is just 2 or 4 now. This is 1, 2. That can't be 4. There's not enough space for a rectangle of size 4 because it can't overlap with its friend here. So that's just 1 or 2 now. Now, what's this one going to join? Yeah, right. Here is how to think about this. What's that one a member of? It can't join green without green being of size 9, which is not allowed. It can't join this, that's a 6 or a 7. So that can't ever get to this cell. And no other circle can get to it, so it's got to join up with this one. But if that's true, this one can't get to that cell, which means the only circle that can get to this cell is this one. So this is a 2 joining to this one. Now that 2 is not... It's not the repeated digit in row 2, so we can apply Sudoku to it. So that's a 4, that's a 1, this is part of a Shikaku rectangle, which is cool because that means that the top row now has to be, this final cell in it has to be picked up by that cell there, which must now be a 7. Now, does that mean that's a 6? Yes, it does. There's a double 8 in the column. That's a 6. Now, that's a circle. So, what does that mean? So, if this comes across horizontally like that, I'm just going to look at that for a second. If it does that, this one will have to pick up that. So that's forced, that's forced. This cell must then join to that one. Don't like the look of that. That doesn't look possible to me. Why? I don't think that works, does it? If this comes across horizontally, that's forced. This cell becomes problematic. Well, the juxtaposition of this cell and this cell become problematic because the only thing that can reach these two cells is this circle, and it can't reach both of them at the same time. So that just doesn't work. So that means this doesn't just come across horizontally. So it must go up, and it must take those cells, I think. And that means we can rectangularize this arrangement. I keep seeing this 6 as like a killer Sudoku clue and attaching it to this one circle, but this is not a 6. Well, it might be a 6, but it's not. We don't know it's a 6, or we don't know it's not a 6. But now, this cell, what's that in? That's got to be in red, so that is now at least of size 6. So it's a 6 or an 8. Now, come on. Oh, and it can't, well, no, it can't be a 6 because it would be in a rectangle with its own number. So that's an 8. And that tells us that's got to be join out here. So now that's got to be to finish the orange. And now we've got more shapes done. Now what have we got to do? Now we've got 2 more circles to look at. We've got the possibility of this one being an 8 though. Now if that's an 8, it comes here. And that doesn't work because you get 3 2s in column 9. Is that right? I mean, that's really beautiful if that's true. Let me just stare at that for a second. If you do that, how do you get to this square? The only way is from this one, so that's a 2. How do you get to this square? Well, the only way of getting to that one is there, so that's a 2, and you get 3 2s in the column, and that's broken. So that's wrong. So that's a 6, which means that we've got 2 6s in column 7. We've got to fill these 2 circles with numbers that add up to 6, don't we? And you can't put 1 and 5 in there. Oh, but you could put but double 3 won't work because then there's no way of making a rectangle in a double 3 way. If these were offset, if this one was here, you could do double 3, but you can't here when these see each other. Not because of Sudoku, bizarrely enough. You could absolutely have double 3 in this puzzle in these cells, but not with this configuration because you can't do bendy rectangles. So that's a 2-4 pair. And that means that the repeated digit in column 9 is, no, I was about to say it's a 2, but it's not. It could be double 4. No, it can't be double 4 because that breaks the Shikaku. It can't be double 4. One of these needs to be 2 because these have to add up to 6. So sorry, yeah, it is a repeated 2. So whichever of these is a 4 is seeing that cell. That can't be a 4. Now I've got a 2-4 pair in row 5 as well, but that might be total gibberish. So what do we do? Do we have to? I've got no idea. I'm tempted to look at the 8 clue here, although the fact that I know this 8 clue has every digit in it. 1. No, that is worth. I think that's got to be memorialised, hasn't it? Because otherwise I won't appreciate the effect of that. So those cells have got to be 1, 2, 3, 4, 7, and 9. Now, in this column we have double 6, so nothing else can repeat in this column. So 1 and 4 can come out of these cells. In this column, the 2 is repeated, so we can't have another 2, and we can't have a 4 because we know there's a 4 in one of those 2 cells. But right, yeah, this is useful, because now look at this one. This one has got a 4 in it somewhere, and the 4 doesn't seem to be there, and it doesn't seem to be there. So the 4 is in one of those 2 positions, and that means I've got 2 4s in row 7, which completes the quota for row 7. So now I can apply Sudoku to the 3 and the 6, which means I get to eliminate 3 from all of those. And 6, although I don't seem to have a 6. Oh, I haven't got a 6 in there for that reason. So that's very, very useful. He said, not actually saying how to do anything with it. Bobbins. Does this 4 disambiguate this? I don't think so. I haven't got 2 repeated digits, or 1 repeated digit in row 3. So now that I've got a 1 3 7 9 quadruple in column 9, and that's real, isn't it? Because the repeated digit is 2. So in this column, I should know what those 2 cells are. They are 6 and 8, because I need to have 1 of every digit in every row, column and box, and 2 of a digit that we don't know. So I still have to put 1 of every digit in every row, column and box. So this is almost telling me that there's a high digit repeating in row 4. This is 6 or 8. So, I've got it. That's 8. It's 8 because look, I've got a 1 2 4 triple here. So whatever this cell is, it is repeating in box 3. So you can't have a second repeating digit. This is really clever. So that's a 6. Now I've got a repeated 6 in this row, so those aren't 6. So now I've still got to put 3. I want to say 3, 7 and 9 into this box. Oh, where does 7 go then? Yeah, 7 can just be placed, because I must put a 7 into this box and it can't be repeating in a rectangle. So that's just a 7, which I don't know if that does anything at all. But these 2 squares have to be 3 and 9. They've got to appear somewhere in this box. So that's a 3, 9 pair. And there's probably some way of resolving that, but I don't know what it is. So this row still needs 4s and 6s in it. So there's got to be 4s and 6s in these cells. And then there's got to be a repeated digit as well. Now the repeated digit cannot be repeated within the Sudoku. So one of these 2 digits. Oh, does that mean that these... Does that mean that this has to be a 1 and repeat here? Or does it mean that, for example, this 1 could come in here? I don't know. I'm not sure about that. I think it might be possible for there to be one of these 2 digits in one of those 3 cells. But how? But hang on, if there's a 6 in one of those cells and there has to be in row 1, that's the repeated digit in box 2. It's a 6. So this can't be a 7 because it would be repeating. We'd have 2 7s and 2 6s. So this is 2, 4 or 9. So what's the repeated digit in this row? We still don't know, do we? We don't know. It's whichever one of these is not 9. This is crazy. It's absolutely crazy. So, what do we look for now? I don't know where to look. I'm sorry. I'm sorry if this is obvious. It can't be obvious. Please don't be obvious. I would really be upset if it was obvious. Do we know what that is? It's got a 6 and a 7 looking at it, which is very disconcerting. I don't know. It might be time to do Sudoku of all things. That's the thing that's a bit concerning. Yeah, okay. Where does 8 go in column 4? It's not there. And it must be in column 4 somewhere, so it has to be here. Which is slightly strange. And doesn't seem to tell me anything. There's a repeated 4. And this digit, therefore, is either 1, 2, 7 or 9, I think. I'm just going to check that. 1, 2, it can't be 3, 4, it can't be 5. Yeah, 1, 2, 7 or 9. But is there some way we can restrict it? No, I don't think so. I don't think there is. I think we have to we have to just say no, there's no way of doing that. Okay, can we do anything in the bottom row? We've got loads of things. Yeah, okay. So that, remember, we've got to have one of each digit in every row. So the 3 and the 4 in the bottom row are in those 3 cells. Now, and then we can apply Sudoku logic to this box. Once we've got a 3 or a 4 in that triple, this cannot be a 3 or a 4. So that becomes a 1, which means that that becomes... Now, I'm just pausing here because this could be wrong. I was about to say this becomes a 3. It does, because the 6 or the 7 is the repeated digit. Good grief. So that becomes a 3 and that becomes a 4. And that's fair enough. So this 4 is looking at this cell. Now, can we eliminate the 4 from this cell? The answer to that is... I don't know. I mean, maybe we can, but I'm not confident that that's logically sound. I know there is a 4 in one of those two, but why couldn't it be the repeat in column 8? I think it might be able to. This 3, that 3 can come out of there, look, because we do know the repeated digit in column 9 is a 2. So I've got a 179 triple here. Okay, I can do something very small with that, because in this 179 triple, the 1 must be in this domino, and then the 1 then can't go about repeating itself within the Sudoku. So we've managed to get some of these digits down a bit further. You've got to put 3. I've got to put 3 in here. So hang on, was that available before? I don't know, maybe I could have got this 3 before, but anyway, that's definitely a 3. Now, that's looking at this cell, which does see double 6, so I can't repeat the 3 in the column, so that's 9. Does that mean that's a 3? Yeah, yes, because that digit is repeating one of those digits. Now, this 9 does play ball and gets me rid of the 7, because again, we've got the double 6. So that's a 9, is it? This is so strange that I can't just write this in. It is a 9 because I've already the repeated digit in this row is coming from low numbers. Yeah, that's fair enough to get rid of these because the 2 is repeating in this column. 1s and 7s. That's the simple deduction. That's as simple as it gets in this puzzle, is when something is in a Shikaku box. So now I've got a 2, 4, so now I've got a 2, 4, 9 triple here. Now that does apply to this because we know the 4s are the repeating digits, so I can get rid of 2 and 9 from here, and this becomes 1 or 7. Now, what does that mean? Because I don't think that's a problem from the Shikaku box's perspective. Whatever this is definitely the repeated digit in this box. So if this was 7, it would also be the repeated digit in the column. I don't know. I could do it a different way. This box over here has a 1 in it. It also has 2 6s. So that can't be a second repeated digit. This is a 7. This is a 1. Therefore, that is a 7, yes, because the repeated digit in the row is a 4. So that does give me 2 7s in this column. And it does mean I can't repeat a 1 in this box. So those squares have to have 1 removed from them. So there are now a 2, 3, 4 triple. And the double 7 means this has got to be a 9. I've got to put a 9 in this box. So that is 9. Now, yes, I think so. So now I've got 3, 4, 5 high digits in row 6. So I've got to put a 1 in this row, which has got to go here. And this has got to therefore be a 2, because I mustn't have another repeated digit. Now, does that mean that is a 4? Yes, because there's 2 8s in the column, so that is a 4. Now, what does that mean for the row? Oh, actually, no, not the row, the Shikaku. So I can remove 4 from all of those. Wow. So this is 2, 7, 9. And I don't believe it. I don't believe it. Because now I've got... What is the digit? I've got to put 3 in this column. Oh, that's it. Yeah, you've got to put 3 in this column somewhere, and it can't go here, it will repeat in a rectangle. So this is a 3. So that's a 2, 4 pair. But what is this digit? This digit, 1, 2, 3, 4, 6, 7, 8, 9. I've got 1 of every digit there, so this can be anything. It can be anything that isn't ruled out by its row. Now, it can't repeat within its Shikaku, so this square, I think it could be 1, 2, can't be 3, 4, can't be 5, could be 6, can't be 7, can't be 8, 9, 1, 2, 4 or 6, all of which are totally possible. That is completely barbaric. 9 here is in the Shikaku, so that's 2, and that's 4, therefore, exactly the same logic. This column is done. This 4, right, what have we got to fill into these 2 cells? We've got the repeat, so we just need the digits that aren't appearing, 2s and 9s. Now, this 6 is repeating in box 6, so this 2, 9, it does eliminate 4 from there, which gets me a 2. That completes the Shikaku, I think. We can do that, therefore, and this must be a 2, so we can divide it all up. Oh, now. Look at this. I've got 2 4s in row 5. So 1 and 3 can be applied naturally to Sudoku. And that's very annoying. I don't believe it. I don't believe it. And that is why you fail. 3 and 4 in row 4. Are they the pair that I think they might be? They've got to go in somewhere, and they're not in there yet. Yeah, so I see these are a 2, 7, 8, 9 quadruple. That's one way to see that. So this is a 3, 4 pair. Oh, this double 2 looks so strange. Is that really right? 1, 2, 3, 4. Yeah, maybe it could be. Do we know? No, I don't know what the repeated digit is in there. Do I know what the repeated digit is here? Not sure. I mean, this puzzle, you'd think it would get easier as you got more and more answers into the grid. I'm not so sure it is getting easier. Now, these 2 cells from the row, one of them has to be a 3. I haven't got a 3 in the row yet. But I still don't have the repeated digit either. So I don't think I know much about that. I know there's a 3 in one of those 2 cells. Okay. So do I have to do these ones then? So these digits must not be digits that are already in blue, because they'll then repeat within their Shikaku. So they're 1, 2, 4, 6 as well, aren't they? They can't be 5. So this isn't 1 or 6. So that's a 2, 4 pair in that column, but that might not be a meaningful thing. Oh no, that we have got double set. Right, this is going to be where we have to look. I'm just going to get rid of 6 from there as well, which I've just seen can't go there. But I've got a 2, 4 pair in this column with a double 7 in it. So this is a real 2, 4 pair, which means that's a 3, which means that's a 4, which means that's a 3, because I've got to put a 3 in this row. Now, does that mean this is 1, 2, or 9, perhaps? Oh, yeah, whatever this is might get eliminated by the 2, 4 pair. Let's actually think very carefully about what this digit is. I think the only restriction on it, bizarrely, is coming from its Shikaku, where it can't be all of those digits, and it also can't be 5. So it is 1, 2, or 9, but we've got double 7 in this column, so the 1 can come out of here, and we've got a 2, 4 pair, so this is a 9. Which of course doesn't mean that I know what this digit is. I still don't know, do I? This is ridiculous. Right, but I now must know what this digit is. This is an 8. I've not got an 8 in this column, so that is 8. There's double 4 in this row, so that's not 8. So this square, again, all I'm doing is restricting it by its Shikaku. I don't really trust myself to do anything else. It's 2, 7, or 9, and there's no repeat yet in column 6 to use. No, hang on. I've got to have a 1 in this column. That doesn't seem to be able to go anywhere apart from here, so I'm going to allege that this is a 1. So that is not a 1. Ah, yeah, double 1 in the first row, that's it. So that's got to be a 2. Now, I was about to write this in as a 1. I don't think that's legitimate, but now this is a 4. And this, sorry, a 4. This is a 6. Double 6 here, so the 9 works. So now we can get rid of the 2 here. That's in the Shikaku. We get a 7, 9 pair. The 7, 9... and yeah, I've got double 4 here, so that's got to be applied logically. So that's a 2. Now what do we do? I know a bit more. I know that is a Shikaku division. I've got a 7 and an 8 in here. Yeah, okay, look. I've got a 7 and an 8 in here. And the repeat is coming in these 3 cells. So I can delete those 7s and 8s from there. So there is now a 6-9 pair in that box. Now, what else have we got that's going to be of any use? Oh, my phone's turned itself back on. We have got... okay, this digit is known, isn't it? Because the repeat here is this one and these 2. So that 6 does frank that one and forces it to be a 7. And in this column, we know it's low digits that are repeating, so the 7 does operate to reduce some things. So I have 2 7s in this row. Yeah, this 4 at the top gets me a 2 at the bottom and a 4 here. Therefore, I'm not going to put that 4 in just for a second. I don't even trust myself to do that. No, it is correct because there's a double 7 in the box. So the 2 here does work. But so does... Yeah, yes. Look at this row. I've got 2 4s in it. So this 2 does work on that. So that's a 9. This box has 2 6s in it, so I'm allowed to eliminate that. Now, am I allowed to put 7 in here? Yes, because the 2 4s. This is 7. Am I allowed to put 9 in here? Yes, the 2 6s. Oh, come on. 2 6s mean that is 8. That is 7. 8 and 7 into these 2 squares must do something. Is this... Do we know what the repeated digit is? Oh, I've made a... No, I haven't made a mistake. I've got 2 4s in this row, though, so that's got to be a 6. Now I've got double 1 in the first column, so that's a 9. That's a 6. Even I think I might be able to solve this now. I need an 8 in this column somewhere, so that double 8's this box, and that square's got to be a 9, because this needs a 9. And I've got 2 2s in this row, so that's got to be a 1. And the last digit in the grid is there. Yeah, that's absolutely ridiculous. Look at this. It's the Shikaku that finishes the puzzle. This cell can only be reached by the 4. So in order to make this column work, we worked this out a bit earlier. It had to be 4 double 2 1. But that is literally the last piece of the jigsaw, to put the 2 in there. And that might be the solution to the puzzle. 1 hour, how does that be 1 hour 40 minutes? That has flown past. I'm just going to tidy up some of the oranging actually, because it's a bit unsightly. So we could make some of these prettier, couldn't we? We could put some greens in them. Let's put some greens in those, and we could make that one green and that one yellow. And then this column needs some blue, I think, and maybe some purple up there. And that could be blue, and that could be yellow. And that sort of shows the finish of the puzzle. Now how on earth do we check this? I presume that's not going to work. I can't blame Sven for that. That doesn't understand that this puzzle's wrong. And that is unsurprising given I've got duplicates all over the shop. I've got 2 1s in the first row. I should only have 1 duplicate in every row, column and box. So I'm just going to double 6, double 2, double 6, double 4, double 8, that's okay. Double 2 there, that's okay. Double 7, double 4. So I think the boxes work. Double 1, double 6. What's repeating in this row? Oh, please let something be repeating. Oh no, what is it? Oh, I made no, double 2, thank goodness. Double 6 there, double 4 there. double 8, double 4. It's a lot of double 4s. Double 7. And what's repeating in the bottom row? Double 2. Right, so it's just the columns. So we've got one repeat, double 1, double 2, double 8, double 6, double 7, double 4, double 6, double 4, and double 2. I think there is only one repeat in every row, column, and box. That's crazy. Absolutely crazy. One of the most bizarre puzzles we've ever done on the channel. No less enjoyable for that. I loved that. I mean, it was fascinating. It's just incredibly taxing. I was supposed to stop yourself looking through the prism of normal Sudoku. However much you might all complain about my normal Sudoku skills, that puzzle definitely. Well, it should have played to my strengths, but I'm not sure that it did. Thank you very much for watching and staying with me if you're still in the video at this point. I hope you had a go at the puzzle. Let me know how you got on. I do enjoy reading the comments, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.